Hi there, welcome to my channel. Before we continue, let's see what is in store for you in this video. First, we will see the definition and notation of a vector. Next, what is meant by equality of two vectors. Then, multiplication of vector by scalar. And at the end, the addition and subtraction of vectors. Definition of vector and vector notation. A vector is a quantity that has both magnitude and direction. Magnitude means the length. A scalar is a quantity that has magnitude only. So remember the difference between a vector and a scalar. A vector with magnitude and direction. A scalar is a quantity with magnitude only. For example, velocity is a vector. Speed is a scalar. A vector can be presented by a line segment with an arrow, known as a directed line segment. Below, you can see three ways of presenting a vector. The first one is a line segment moving from point A to point B. The second form of writing or presenting a vector by using capital letter from A to B. Therefore, it is written as AB, and on top of it you have the arrow. The third form of writing the vector is by using a small letter A, for example. And below the A, you have the symbol to indicate a vector. Equality of two vectors. Negative vector of AB has the same magnitude as AB, but its direction is opposite of AB. Below, we have two arrows. One is moving from point A to point B, which is labeled as AB. The second arrow is moving down, that is from point B to point A. Therefore, it is written as BA or negative AB, since it is going in opposite direction. A zero vector is a vector whose magnitude is 0. It is denoted by 0 with symbol vector. Two vectors are equal if both vectors have the same magnitude and direction. Multiplication of vector by a scalar and the parallel condition of two vectors. When a vector A is multiplied by a scalar k, the product is Ka. Its magnitude is k times the magnitude of the vector A. For example, if vector A is multiplied by 2, the product is 2A. Then its magnitude is 2 times the magnitude of vector A. Number 2. The vector A is parallel to the vector B if and only if B equals to Ka, where K is a constant. In some cases, lambda is being used instead of K. Remember, if A parallel to B, it can be written as B equals to Ka or A equals to KB. Number 3. If the vectors A and B are not parallel and HA equals to KB, then the coefficient of vector A and vector B equals to 0. Therefore, in this case, H equals to 0 and K equals to 0. It is important to remember that when two vectors are parallel, so equation can be formed as B equals to KA. If not parallel, then the coefficient of the vector equals to 0. Example 1. If vector A and B are not parallel and K minus 7A, 5 plus HB, find the value of K and H. In this case, vector A and vector B are not parallel. Therefore, the coefficient of vector A and vector B equals to 0. So if you look at the solution given, the coefficient of A is K minus 7, which is equals to 0. And the coefficient of vector B is 5 plus H, which is equals to 0. So, solving this equation, you will be able to find the value of K and H. Addition and subtraction of vectors. The addition of two vectors U and V can be written as U plus V. The result of this addition is a vector which is called the resultant vector. For example, let's say you are given a vector U plus with another vector V. The result is a resultant vector U plus V. Therefore, remember, when two vectors with the same direction is added up, the resultant vector has the same direction with both the vectors, and the magnitude equal to the sum of the magnitudes of both the vectors. Or, if the vectors are not in the same direction, for example, given U, given V, therefore the resultant vector is U plus V. Look at the point where vector U starts and vector V ends. So that is the point joining U plus V. Addition of non-parallel vectors. Addition of two non-parallel vectors U and V can be shown by using two laws. Triangle law of addition. In order to obtain the resultant vector AC, you need to travel from point A to point C. Or another route will be traveling from point A to B, and then from B to C. So the equation is written as AC equals to AB plus BC. Now when you form equation, make sure the letter in the middle, they are the same. In this case, the letter B. If you cancel out B, then you'll get the resultant vector, that is AC. Okay, AB equals to U and BC equals to V. So AC equals to the resultant vector U plus V. The second law is parallelogram law of addition. You can use this law when you are given a parallelogram. When vector AD is added up with vector AB, the resultant vector is vector AC, where vector AD is V, vector AB is U. Therefore, the resultant vector is U plus V. Let's look at another example. If you are given a parallelogram PQRS, for example, when vector QP is added up with QR, the resultant vector will be QS. The diagonal is the resultant vector if you are given a parallelogram. Expression of a vector is the linear combination of a few vectors. Okay, Polygon law of vectors. Okay, in order to find vector PQ, okay, you start from point P and then you end up at point Q. So I'm going to start with PU plus UT plus TS plus SR plus RQ, and the resultant vector of these vectors will be PQ. Example 2. You are given a diagram with vector PQ and vector RS. First question, find the resultant vector. Therefore, the resultant vector equals to PQ plus RS. The second question, you are asked to find the magnitude. Okay, please take note. The symbol modulus PQ plus modulus RS indicates the magnitude. So remember, in vector, modulus of a vector indicates the magnitude of the vector. So magnitude of PQ plus magnitude of RS. Using the Pythagoras theorem, in this case, you can find the magnitude of the resultant vector. Okay, express vector PQ in terms of x and y. You are given vector x, vector y, and vector PQ. The question is, express vector PQ in terms of x and y. So here, starting from point P, we have x, 1x, 2x, 3x. Okay, so moving in the same direction as the given x vector, therefore it is 3x. Then from this point you move up, okay, that is vector y. Therefore the resultant vector PQ will be 3x plus y. Okay, express vector PQ in terms of x and y. Again, you are given x, vector y, and vector PQ. So in order to get vector PQ, we need 1y, 2y, okay, in the same direction. If the arrow is going in opposite direction, then you need to use negative sign, since the 2y is parallel to the given vector y, therefore it is positive 2y. Next, okay, you go up, x, vector x 1, vector x 2. So it is parallel to vector x, therefore it is positive 2x. Therefore, the resultant vector PQ is 2x plus 2y. Okay, this slide is quite important when you are solving vector questions later. Okay, given 2ab equals to 5bc. So you may rewrite it in fraction form as AB over BC equals to 5 over 2 or AB equals to 5 over 2 BC. Now you know the ratio between AB and BC, so you may write it in the diagram, AB as 5, BC as 2. So based on these ratios, now we can form other equations such as AB over AC. So the ratio between AB and AC, that will be AB is 5, AC total will be 7. Or rewrite the equation as AB equals to 5 over 7 AC. Okay, or you may find the ratio between AC and BC. So AC is 7, BC is 2. So in order to find AC, so AC equals to 7 over 2 BC. So remember, this lesson is very important when you are solving vector question later on. Okay, the diagram above shows a parallelogram OABC. It is a parallelogram. M is the midpoint of BC. Vector OA equals to A. Vector OC equals to C. Find the following in terms of A and C. The first question you are asked to find OB. Okay, find OB. OB is the diagonal of the parallelogram. So here I am going to use parallelogram law to find the resultant vector OB. So OB here equals to OA plus OC, where OA is A, OC equals to C. So OB equals to A plus C. If you don't remember the law, please go back to the slide and listen again. Okay, next find MB. MB, if you look at the given diagram, it is also mentioned that M is the midpoint of CB. Therefore, it is half of CB. Since this is a parallelogram, therefore the magnitude of vector OA equals to the magnitude of CB. So if OA is A, then CB is also A. Therefore MB equals to 1 over 2 CB, which is equals to 1 over 2 OA, or equals to 1 over 2 A. Okay, find OM. So vector OM. So we must start from letter O and end up at point M. So here I have two routes to follow. The first one will be from O to C and then C to M, or the second route will be from O to A, then B, then M. Therefore, in this case, I'm going to choose the first route, that is traveling from O to C and then from C to M. Therefore, it is written as OC plus CM in order to get OM. Now, see the equation written. OM equals to OC plus CM. The middle letter CC have to be same if you are using triangle law of addition. Okay, here CM equals to MB. So the second line is written as OC plus MB. MB, okay, we have found the MB just now, that is 1 over 2A. Therefore, OM equals to OC is C plus MB is 1 over 2A. So OM equals to C plus 1 over 2A. Thanks for watching. Hope to see you in next episode. For more videos, please do subscribe.